Hey Bobcats, Mr. Peterson here. Today we're going to look at how to transform some exponential functions. We'll also look at logarithmics, but we'll save that for the second part of this video. This part we'll just focus on log or exponential transformations. All right, so here we're going to do it with a calculator and just kind of examine some of the cool things that happens when you play around with these. So first of all, it's important to remind you that with exponentials there's not one single parent function. There's a different one for each base, and we're just going to keep it simple. We're going to try 2 to the x power as our parent function. All right, so I have that there. I'm going to go down and I'm going to keep that there the whole time. I'm going to work off of f of 2. So our blue line is our original parent function, and I just want to kind of compare and contrast that when we change it around and do some things with it. So here's 2 to the x. But I want you to see what happens here when we do 2 to the x plus 1. All right, you notice there's our red one. It's the new one. It shifted vertically 1 unit. Okay, that's interesting. Well, what if we do 2 to the x minus 1? Okay, look what happened to the red one. It shifted down 1 vertically. All right, so key idea here, key takeaway here is that if you want to do a vertical translation, you need to change the number back behind the exponential. That's the k. If we add, it's going to do a vertical shift, and if we subtract, it's going to do a vertical shift, but downward instead of upward. All right. Well, you might be asking yourself, what about doing a horizontal shift? Okay, so I'm going to clear that off there. There we can see the red one went back to being the parent function. Well, to do a horizontal shift, we need to play with the number up here in the exponent. So let's do 2 to the x, take away 1. And remember, the blue one is the original parent function. You can see that when we did 2 to the x, take away 1, the red one shifted 1 to the right. Okay. Wonder what might happen if we add 1. If we add 1, it shifts 1 to the left. It shifts 1 unit to the left. So again, here, key takeaway is that if you need to do a horizontal translation, and again, that's the h, the variable here is the h. If we want to do it a left to the left, we were going to add a number. If we want to do it to the right, we're going to take away a number up here. All right, well, what about a vertical stretch? Well, to do that, we need to multiply by a number out here. We're going to keep it simple, 3 times 2 to the x. Remember, the blue one is our original parent function. The red one has a vertical stretch now of 3, a vertical stretch of 3, all by multiplying by a 3 out front. And if you need to do a vertical compression, well, we need to multiply then by a number that's between 0 and 1. So let's try 1/3. 1/3. All right, and we do that. You can see here is our vertical compression. It got pressed down vertically, and again here the factor was 1/3. All right, so again, key takeaway here is that if you need to do a vertical transformation, we need to change the multiplier out here. If we want to do a stretch, it needs to be times a number greater than 1, and if we want to do a compression, it needs to be times a number that's between 0 and 1. All right, well, what about a horizontal stretch? You might be asking yourself, well, in that case, we need to play around with the number again up here in the exponent. Again, you're seeing horizontal here. We're always messing with the number in the exponent. Whereas vertical, we're messing around with the number either before or after, the times or the adding or subtracting behind it. But to do a horizontal stretch, what we're going to need to do is we're going to need to multiply by a factor of 1 between 0 and 1. So let's try 1/3 up here. All right, and when we do that, that actually does a stretch by a factor of 3. That does a stretch by a factor of 3. It was stretched 3 times as long, even though we're multiplying by the 1/3. And then let's try again. What if we tried making it be a number bigger than 1? What if we try 2 to the 3x? Well, that, as you might guess, that does a compression. That does a compression by 1/3. A compression by 1/3. So again, if you need to do a horizontal stretch, you need to multiply in the exponent by a number that's between 0 and 1. And if you need to do a horizontal compression, you need to multiply by a number that's greater than 1 up there in the exponent. And then there's one last one. Here's back to our parent functions. What if we want to do a reflection? Well, if we want to do a reflection over the x-axis, we need to make this number out front be negative. There we go. You can see the blue. There's our original one. We have reflected it over the x-axis. All right, well, what about a reflection over the y-axis? Okay, well, to do that, we need to come up into the exponent and make it negative. So there we go, negative 2 to the negative x. Hit enter. There you can see we now have a reflection over the y-axis. So again, kind of the key takeaway here is that if you want to do a reflection, if you need to do it over the x-axis, you need to put the negative out before the exponential equation, and if you want to do a reflection over the y-axis, you need to put the negative up into the exponent. And all of these cool properties are in your book. The more you do them, the more you'll memorize them, but they are in your book on page 237, I believe. Yeah, or no, excuse me, 537. All of these properties are right there. All the things that we just discussed, they're right there. Why don't we try a couple problems? I'll let you do that. Here's one, and here's another, and here's another, and here's another, and then with that one being done, we'll see you back tomorrow with logarithmic transformations.